All right, it's time to solve a system of linear equations with 3 variables by using Cramer's rule. All right, I'm going to leave a little space here, so once I find these values, I'm going to be able to plug them in and then be able to get x, y, and z. All right, I'm going to go ahead and use this whole page to find the determinants that I need to get the variables. So remember, D is the coefficient matrix. I'm going to skip a little space here and do D subscript x, which means the x column is going to be replaced with these constants. And I'm going to keep the y and the z columns. I'm going to go ahead and build the D subscript y matrix. So looking back up here at the D matrix, I'll keep the x column and the z column, replacing the middle column, the y column, with these constants right here. And lastly, I'm going to go ahead and do the setup on the D subscript x matrix. Oh, excuse me, D subscript z. So the x and y columns remain the same as in the original D matrix. All right. So to find the determinant of this third order matrix here, I don't see any zeros. That's not good. So I'm left to decide what row or column do I want to do an expansion around. Well, I might want to just work with this first column right here, so I'll lightly circle it. So 3, 2, and 1 are going to be the factors, and remember the sign chart. 3 will start out positive. This number here would go negative, and this number here would stay positive. Okay, so I'm going to take the factor 3 and find its minor. So cross off the top row in the left column, and I'm left with these 4 values right here. Now I'm going to return to the second element, and I see a -2 times this second order determinant. So crossing off this row and this column, I'm left with these top 2 numbers and these bottom 2 numbers. Okay, and returning here to this column that I've circled, I see +1 and then times its minor. Scratch off that row, that column. I'm left with these 4 numbers. All right, to evaluate this 2 by 2 matrix, the down arrow multiplied, so 3 times 3 is 9, minus, and this product is -4. Over here, -6 minus, never plus with determinants, minus, and that product is 4. That product is +2 minus, and this product is 3. So this will become 13 times 3 is 39, minus 2 times this value is -10, plus 1 times, and then this added is -1. So this looks like 39, excuse me, plus 20, and this multiplied is minus 1. So that looks like to be 58. All right, so now we have to find the determinant of this third order matrix. I don't think I'm going to choose this same column right here. I might choose a different column or a different row. I think I'm going to choose the third row. These are all positive numbers, but remember, put the signs above these numbers. So this is in the positive position, the negative position, and the positive position. So let's choose 2, crossing off the row and column. It's easy to make a mistake, so just kind of double check to make sure you're grabbing all the correct signs. Okay, moving over to 4, it's going to be a minus 4. Row and column disappear. 16, 1, negative 9, negative 1. And then returning to my circled row, that's going to be a plus 3 times its minor. This determinant, negative 2 times negative 1 is 2 minus, and then that product is 3. Right, that's negative 16 minus, and that product is negative 9. It's 48 minus, and that product is positive 18. All right, so doing this work is negative 1. So negative 1 times 2 is negative 2. Inside here, let's add these. We're going to get negative 7 times negative 4. That's plus 28. Here we have 30. 30 times 3 is 90. So going straight to the calculator, that looks like to be 116. And I'm going to stop right here. Once I get 58, the value of the D matrix, which is all the denominators, I'm going to make sure that these numbers that I get in these next 3 determinants would be a good multiple of this. For example, I'm going to be putting 116 divided by 58 right up here to get X. And I believe that's exactly 2. So that's a good number. I probably didn't make a mistake. All right, evaluating this determinant, what row or column do I want to circle? Probably the bottom row. Again, there's some positive numbers. Put the signs, plus, minus, plus. And let's do expansion by minor. So that's going to be 1 times the minor. And here, this is a minus, so that's minus 2 times the minor. And the last factor is plus 3 times its minor. All right, that's negative 16 minus, that product is negative 9. Negative 3 minus, that product is 2. Negative 27 minus, that product is 32. So again, in here, that's negative 7 times 1 is negative 7. Moving over here, this is negative 5 times negative 2, which is plus 10. Here it looks like that's negative 59 times 3. Oh gosh. What is that? That's 60 times 3 is 180. 177, I believe, minus 177. Looks like negative 174. I immediately would take this negative 174 and I would divide it by 58. And I think that's a good number. So I don't think I made a mistake on this one right here. Just kind of a little, you know, stepping stone along the way. All right, scanning rows and columns. I guess I could either choose the first column or the last row. Won't matter. We should get the same answer. I'll just choose the bottom row again. Oop, I forgot to put the plus, minus, plus. That's +1. This becomes -4. I think that was a 2. And -9. It's +18 minus 48. -27 minus whatever that is, 32. 9 minus, and that's -4. All right, so this is -30 times 1 is -30. Again, this is -59 times -4. Oh gosh, that's 60, 240, 236. That's +236. And then here we have 13 inside here, and 13 times 2 is 26. So let's see if that's a good number. That sum is 232. All right, so now taking all the values here, let's go back up to the top. Let's plug everything in. Probably didn't save myself enough space here. I'll try and make it work. So d subscript x is 116, and this denominator is 58. So that's equal to exactly 2. Okay, now for here and here, d subscript y was -174, and we're dividing by 58. And I believe that's going to be exactly -3. And then finally, d subscript z was 232 divided by 58. And I want to say that's exactly 4. All right, so to record our answer, it'd be 2, -3, 4. All right, so that's evaluating a third order determinant. A lot of work. It's just easy to make some mistakes and stuff, but you know, it just kind of lines out pretty nicely. All right, so if you're good, wonderful. If you want to do some more practice problems, just hang around. If you want to see the practice problems and try them on your own and then come back to make sure that, you know, you've got the same answers I do, then feel free to do so. All right, so I'm going to take a little bit of time and do 2 more examples, one of a 2x2 and one of a 3x3. And you don't have these examples, so I just kind of created some new ones real quick just for some extra practice. So if you want to stop and just record these on some notebook paper just for some extra practice. All right, we're asked to use Cramer's rule to solve the following systems. This one isn't going to be too bad. If I was given a choice on how to solve this system, I would do elimination, because I see that if I have a -2y here and I added these down and eliminated the y's, I would get an easier solve here. But I'm told to use Cramer's rule, so that's what I have to do. All right, so I'm solving for x and y. So the first thing I do is I build my little equations here. They help remind me what I need to find. So I need 1, 2, 3 determinants. So the D determinant contains the coefficients, not 2 and 3. So 3, 2, 2, 2. I need D subscript x and D subscript y. So x column gets replaced with 2, 3, and I keep the 2 2's here. And likewise dy. Replace the y column with the answers 2 and 3. Keep the x column of 3 and 2. All right, so how nice. It's a 2 by 2. So let's just go straight to the determinant. That's 6 minus 4. So that's 2. So it'd be 4 minus 6. So that's negative 2. That's already good. And this determinant would be 9 minus 4. So coming back up here, d subscript x divided by d, so that's negative 2 divided by 2, so x is negative 1. And dy is 5 divided by 2, and I'd just leave it as 5 halves. I'd record my answer as an ordered pair, negative 1, 5 halves. All right, I have one more example of a linear system with 3 variables, and I don't have enough room here, so I'm going to turn this paper over to the back, and we'll do one more. Oh, sorry about that. I missed a 3z. Sorry about that. Plus 3z equals 10. All right. Given the choice, if I wasn't going to use Cramer's rule, I would use that previous method we found where you grabbed 2 equations twice and you eliminate the x's or y's. So if this is me, that's the method I'm going to use, where I would probably try and eliminate the y's and get 2 equations with x and z, solve those, and then back substitute. But we're asked to use Cramer's rule, so that's what we have to do. Try and remind myself to leave some space here. All right, the coefficient matrix, 2, 2, 3, 4, negative 1, 1, and 5, negative 2, 6. Replace the x column with the answers, leaving the y and the z columns alone. And let's do the setup on the d subscript z. All right, now going back to the D matrix, let's see if I can get it all on here. All right, let's choose a row or a column, doesn't matter. I guess I'll just choose the first column. Okay, so I need a plus, a minus, and a plus here. and then working inside the brackets. So I need to change that to plus. So all of this adds to -4 times 2 is -8. Minus, okay, well, it might not be minus. Let me hold up and see what's going to happen here. Subtracting a negative is plus, so that's 18. 18 times -4 on the calculator should be -72. And here, this will be 5 times another 5 is 25. Looks like -55. All right, let's expand here. Maybe the last column, even the top row, whatever you want to do. I'll do the last column. Don't forget the signs, be plus, minus, plus. So start with +3 and find its minor, crossing off rows and columns and remaining elements. Slipping down here, this is -1. Row, column, disappear. 10, 2, 1, -2. And then a +6 times its minor. That's +10, always minus, and then whatever you get here, which is -1. -20 minus, and then whatever you get here, which is 2. -10 minus, and that's also a -10. All right, this will be 11 times 3 is 33. Go inside here and get -22, but times a -1 makes that +22. Let's change subtraction to addition, change that sign. -10 plus 10 is 0. That's nice. 0 times 6 is just 0. So we will end up with 55, which is great because of the -55 we found here. All right, so 2 more, and then we can get our variables. All right, so I don't know. Yeah, rows, columns, doesn't matter. We'll just work with the bottom row. So this sign is positive, negative, positive. All right, so it looks like this is going to be 25 times 5 is 125. Inside here is -10 times -1 is +10. This would be -50 times 5 is -300. Ooh, okay, so what's that? -165, which I'm going to stop and check to see when I divide this value by 55, -55. It is a nice number, it's 3. So I feel like I did this one correctly. And finally, the last one. Maybe I'll just use the bottom row again. Always write down your minus first and then go back and get that other product. All right, reaching inside here, change that, add, that's 0, so 0 times 5 is just 0, so skip that. Negative 50 here, times negative 2 is 100, and this would be negative 10 times 1, negative 10. Wait a minute, that's not right, is it? I got 90. For some reason, I'm thinking that shouldn't be, that should be negative 110. Ah, what did I do here? Oh, this should have been a negative 2, shouldn't it have? Shoot. Maybe you saw that way back when. That should have been a 2, negative 1, negative 2. So let me go back in here, so sorry, and change this. So that would have been a minus negative 2. Because it should have been minus negative 2, which would have made that a plus 2. There we go. So that's negative 50 times 2 is negative 100. So that makes it negative 110, which is going to work out nicely. Whew. All right, back to the top. Let's put all these values in to get our variables. So x is negative 1. dy was negative 165, and d was negative 55. And I believe that's positive 3. And this is negative 110 divided by negative 55, which is a nice 2. So the solution is negative 1, 3, 2. Okay, all right, that's it.